I'm Sam Walton. I'm the project manager on the Ōrākei Infrastructure Projects. We're down here on the Ngāpipi Road Bridge. We're constructing the Ngāpipi Pedestrian Bridge directly adjacent. So it's a $6.5 million bridge. It's 4 spans. One of the key aspects of this project is that we are utilising HEB from start to finish.
My name's Andy Miller. I'm a chartered civil engineer and I work for Auckland Transport. We're going to have a separate cycleway and footway, which is currently shared on the existing Ngāpipi Bridge. And this is a very large part of AT's strategy around east-west cycling and pedestrian manoeuvres. We've had quite a lot of challenges down here, not to mention the weather, the tides, marine traffic that navigates underneath the existing Ngāpipi Bridge.
So my name's James Chamberlain. I'm a project engineer for HEB Construction. What's unique about this project is we'd originally planned to place all the beams, standard procedure with cranes and stuff like that. But as we looked into it further, we found that it just really wasn't feasible. Where we're going to be placing the beams on Tamaki Drive, trying to get closures there is an absolute nightmare. It's a pretty major route. So the decision was made reasonably early on that we needed to place them utilising the jack-up barge. And every beam has been unique, so we've had to come up with unique ways of placing every beam.
We are restricted to floating only because with the weight of the beam, the 4 span, we cannot have a crane positioned on it to actually lift and place the beam. So we'll strip the jack-up barge right down, install the truss, install the beam, and then float it in and use the tide, and a jacking system will lower it down into place. So there'll be no need for any lifting.
So my name is Ronald Yocom. I'm a project manager for Auckland Transport. So on a day-to-day basis, we got a competent designers and construction monitoring team. I think the project is going well so far. We're on track. The quality, the inspections, and the progress of the project are attended well.
My name is Gareth Cole and I am the production manager here at Pjk Trust. So we supply to commercial and residential companies. We do a lot of roading work for NZTA. We also do a lot of commercial projects up in Auckland. Due to span 2, due to the nature of its location, it was in a marine environment, so it needed to have an extra wall thickness. A typical Super T would be 100mm wall thickness, where this one was 125. So a typical Super T would weigh between 40 and 60 tonne. This particular span 2 weighed 86 tonne. For the building process for a beam like span 2, we will get a set of IFC drawings, and then from that we will order the reinforcing. And then when the reinforcing is done, we then place the reinforcing into the mould, and then we will run strand into the mould, and then we have boats that go in to fill the voids of the beam. And when we have final approval, we will then order the concrete, and then we will pour the concrete into the beam. So a typical beam like span 2 would be approximately 25 cubes of concrete, approximately 5 cube a truck. And we cover the beam up, and then the following morning we will then de-stress the beam, and then we'll be able to then lift the beam out of the mould. And we certainly enjoy the challenge of something new, which again pushes the guys, to out of their comfort zone, and it certainly is good to learn new processes and new ways of doing things.
Basically, the carriage that's going to be bringing this beam up is going to be about 60 metres long. At the moment, we're just in our final phases of placing the last Super T beam for the bridge. It's been a pretty long few months trying to get all these beams in position, but yeah, we're definitely on the home straight now. The one thing that's keeping me awake at night is everything. There's so many parts to this puzzle, and we need to make sure that we don't forget any of them. So today we're landing Pjk Trust. We'll be using this to support the Super T beam, which will be floated into position on the bridge. We'll bring it in at 6:45 a.m. in the morning on a 3.1 metre tide. We will then sit there and let the tide go out. As the tide goes out, the beam will be lowered. Why this is happening, we have adjustment in the beam, so we're able to move the Pjk Trust in the backwards and forwards direction. Worst case scenario is that the beam could fall off the barge. As we're landing the beam, we're also going to have a number of ballast tanks sitting on the barge, which we'll use to compensate for the weight of the beam. So prior to the beam heading out, we'll have 3 30,000 litre tanks full of water, These will be emptied as the beam is landed, and 4,000 litre tanks will be filled with water inside the Pjk Trust.
The first most nervous point was when I left the port this morning. It was a tough decision to a go, no go. And then, yeah, when it came in, watching it come in over the headstocks was quite nerve-wracking as well, because obviously we've done as many site checks as we can, but you're probably not going to pick up on absolutely everything. So it's going down into place, and it's going really well. As the jack-up barge lowers with the beam on it, on the tide, the beam will come into position on the headstocks, so the weight will then transfer from one side of the jack-up barge to the other. The jack-up barge will want to tip over. So to stop that tipping and flipping of the jack-up barge, we transfer water from one set of tanks to the other, and that levels off the barge as it lowers on the tide. There's probably not one challenge, but a multitude of a heap of small challenges that we've had to overcome. A big one has been the ballasting process, getting everything positioned right on the jack-up barge to ensure that as it comes down, the whole thing's not going to tip over or slide off. The sheer amount of temporary works that's gone into it, the endless amount of design and redesign, it's all been huge challenges. We're working to millimetre tolerance. We have adjustment all over the place with a whole lot of independent jacks that can be moved, small amounts of water that can be shifted for ballasting. So it's a real art. It comes in roughly the right position and then continuously adjusted right down to the very last millimetre and then placed, and then we pull it away. The two tugs there provided by Thompson tugs, they'll sit there and keep positive pressure on the barge, keeping it in position right through till the beam is in position.
Today is going really well with the final positioning of span 2. HEB have put a tremendous amount of technical work into the temporary works and the placing of this span. It's almost in place at the moment. The timing, tide-wise, weather-wise, and technically is all come together really, really well. So well done, HEB.
It's been months and months of planning, a lot of temporary works design. We've had the crew involved. Everyone's been involved right from the start. They've worked tirelessly on this. It's a real team effort. It's gone well, and that's a real tribute to their hard work and effort that they've put in. A nerve-wracking start and a happy, successful finish.